Hi, in this video we are going to look at the piezoelectric effect. The piezoelectric effect is the phenomenon which is a property of piezoelectric sensors. The definition of a piezoelectric effect is given on the slide, and we're basically saying that it is the appearance of electric polarization in a material that strains under stress. So let's just pick this apart and let me just explain this to you. So let's say you take a solid material, okay, and you apply a stress on it. A stress means a force or a pressure that you apply on it, right? So if you apply a force or a pressure on a particular solid, what do you expect? Let's say you apply a compressive force. You expect the material to deform. You expect the material to change its length, right? To compress. If you are applying a tensile force, you expect the material to expand, right? So this expansion or compression is called strain. Okay, so when you apply a stress, you have a strain on the material. And when you have a strain in piezoelectric material, in addition to having a strain, you also have a voltage or a charge develop across two faces of the solid. Okay, so all materials strain when a stress is applied on it. But for piezoelectric effect, for piezoelectric sensors or piezoelectric materials, in addition to the strain, you also have a electric polarization, which is either a voltage or a charge developing across two faces of the material. Okay, so let's just take a very simplified view as to how this can actually happen. Okay, so let's take take a look at the crystal structure of a piezoelectric material. So the structure is shown here. So okay, so it contains two different particles, a yellow particle here and a blue particle here. And let's assume that the yellow particle is negative while the blue particles are positive. When there is no stress or strain on a material, the material is electrically neutral. There is no electric polarization. There are no electric fields in the material as a whole. Okay, and so what we can assume is both in the x and the y direction, the fields are zero. Okay, so the charges are distributed in a way that the polarization between this negative particle and the positive particles cancel each other out, right? So there will be some field between this negative particle and this positive particle in probably the upward direction, and then there will be a some kind of a field in this direction and some field in this direction. So if you take the y components of the fields, they cancel out. Similarly, the x components of the field also cancel out. Okay. Now let's apply a compressive force in the horizontal direction on this particular crystal. So what happens if you apply a compressive force? These two positively charged particles are going to move closer, right? So this is what is going to happen. So these two positive particles are going to move closer towards the y-axis and further away from the x-axis. Okay, let's assume that the distance remains the same. Now, what does this result in? There was a neutrality of electric field here, but that no longer holds because these two atoms have moved, and therefore now you have a net positive charge in here while you have a net negative charge at this point, and therefore you have electric polarization which is pointing downwards. Okay, now notice what's happening here. We have applied a force in the horizontal direction and the electric polarization is developing in the vertical direction, right? So in piezoelectric materials, that's possible. So you can have strain in one direction and the polarization appearing in the perpendicular direction. Okay, or in other material, which I'm just going to show you in a moment, you can have parallel polarization, which means that You apply strain on one particular direction and you get a polarization in the same direction. So let's take a look at that. So let's take the same crystal and now apply a compressive force in the vertical direction. Okay, and then you see that you get a polarization in the same direction as the compressive force. Okay, so that's parallel polarization. So uh, hopefully that gives you a sense of what piezoelectric effect is all about. There are more details in the readings that I have suggested. If you're interested, you can take a look at that.